All right, so what I would like to do is quickly review what we did last week so we can add one more thing to it. So if I have f of x and I add 2 to it, what am I doing to the function? Right, we're moving it up, okay? If I had f of x minus 2, what am I doing to it? Right, okay? So if I have f of x minus 1, what am I doing to it? Down. And unsurprisingly, I'm about to ask you about f of x plus 1. I go left. All right, so we know about...
Like if the minus is on the other side, it's still the same.
Not quite sure what you're saying.
Yeah.
Okay, great. All right, so we also looked at flipping things. So we looked at using reflection lines. So if I have negative f of x, what am I flipping this about what?
What?
You said both of them.
The y axis.
Ah, you can't write and speak at the same time. Which axis is it?
Y.
X. All right, so you're going to flip it about the x-axis. So that means if it's inside, it's the y. Because I can't speak and write at the same time. That's why I should never have written rotate. Flip. Yep. Remember, multitasking is a myth. What? Anyway, it doesn't work, as I'm living proof of right now. Okay, so that's what we looked at last week. All right, we're going to add one more thing to it. So instead of just moving things around and flipping them, we're going to stretch them today. So what we're going to do is, if I have, so this time I'm going to add a letter. So we've got f of x, right? What if I said a f of x? Okay, I'm going to stretch it. Do you think I'm going to stretch it long ways or wider? Is it going to be taller or wider? Okay, so we're going to stretch in the y direction, right? So taller, okay? So we're going to make it taller. What if I said f a of x? Okay, it's going to be wider. So we're going to stretch it in the x direction. Now, the slight complication about this, though, is this stretches a amount. This stretches 1 over a amount. Right, so let me show you what that means. So it'll make sense when we look at an example, right? It makes total sense. Because if you're trying to stretch this horizontally, right? You're stretching that horizontally and this vertically, you need to get the bits closer together, right? Because you're going to stretch, you're going to smush it this way. Okay, let me show you what I mean. Let's save that and do some examples. Glad you agree. All right. So if I have, let's just start with the most basic thing we possibly can, all right? F of x, oh my gosh. What is it? Wow. All right, we're going to pretend this is awesome. So I'm going to bring this down a bit just so that we've got some coordinates. Okay. So I'm going to say that this goes through -2 and 2. Okay. So if I want to stretch this graph, all right, so let's do it in colors. So I'm going to do 2 f of x. So what direction did we say this stretches? Y. All right, so this is going to stretch that way. So what I need to do is make this wider. So actually what I should do is give you another coordinate down here, shouldn't I? Let's make this -4. Okay, so if I want to do this twice.
This graph is now dropped.
No, it's not, clearly. All my scales are just different. That's fine. Okay, so if I want to stretch this graph, what do you think needs to change? What do I do to all 3 coordinates? Add 2. Why am I adding 2? Okay. Multiplying. Okay. So we're actually multiplying by 2. Think of this as like a scalar, as a multiplier. Am I doing that to all my coordinates? Just the y coordinate, right? I said I'm stretching this vertically. So the x coordinates aren't going to move. This is going to become, right? Let's say that this kept going. This is -8. All right. So if I've just got a number on the front, all I'm doing is changing the y coordinate. Let's see if you can figure out what I should do here. What if I'm doing -2 f of x? So what's changing now? I'm flipping it. Yeah, so I'm multiplying it by -2. So what should I do with my graphs, my points? Good. Am I doing anything with those? No? No. All right, thank you. You're very welcome for my wonderful art. Okay, so we're flipping it. It's -2, so it's upside down, and the scalar is still 2, so we've gone from 4 to 8, but it's in the positive now. Hey, what happened to you people? Oh, okay, cool. Hello. All right, so this time we're stretching it this way, but then we're also flipping it because of the negative. All right, let's just get a new page, I think, because that's just a disaster. All right, so let's do it when we're stretching it horizontally instead of vertically. All right, so let's look at something. Actually, let's not do that yet. So if I have f of x is going to be the red one. Oh, man. We're going to pretend that does not bend. All right. So I am going to do, let's do that. This is 2 and this is 6. Hey, be nice to me. All right. What if I said the function 2x? Ah, well done. So remember, this one is being stretched horizontally, but the factor is not a, it's 1 over a, right? So what I'm actually doing, I know it's amazing. So I'm halving both my x values. So this one becomes 1 and this one becomes 3. All right, so then I have. Yeah, it's making it skinnier, right? You use a negative number, you flip it, right? So same thing, if you use a fraction, then you're making it bigger. So really good question. Let's do one of those. All right, so again, this is a horizontal thing, but what happens if I need 1 over a? What's that? Right, it's 1 over 1 over 2, which is 2. So this is when you stretch it out, okay? Because this is 1 over 2. So then what do my new coordinates become? What are my coordinates? 4, 0, and 12, 0. Okay, so this is going to be 4 is about here. 12 is somewhere over here. Wow. Shut up, shut up. It's amazing. Oh, it's a really good point. I've drawn that rubbish. Hey, good point. Hey, unintentional puns are my favorite. All right. So we are stretching this one or shrinking it. Okay. So just like if you increase the gradient, things get steeper, right? Isn't that what's happening with the purple one here? You increase the number out the front, which is kind of almost like a changeable gradient. So you have to make this steeper and smaller. But then the wider one, right? If the gradient is half, it's more spread out and it's climbing slower. All right. So that's what we're doing. All right. Let's try and put some of this stuff together.